Yeah, let's do a stack machine for this language, x reverse. Remember the reverse, where x is, let's say, AB star. This is actually a language which is very convenient to make on a stack machine. It's not so hard to make a grammar for this. We did it a couple times ago, but it's not really difficult at all to make a stack machine. Because of the way that a stack machine stores things, it very naturally stores strings of this format in a really nice way. For example, so something that has this format, x followed by x reverse, would be something like ABAA, AABA, right? This is the x, this is the x reverse. Now, as you read the string on, and you're using a stack to process this string, what you can do is you can read the first half, read this part, and just push the letters, like the letters themselves, onto the stack. The result of this, if you're doing it right here, would be A goes on the bottom of the stack, and then B next, and then A next, and then A next. The stack actually would, after you read the first half there, the stack would say AABA. Because of the way the stack works, you're putting stuff on the left every time, it ends up on the stack in the reverse order, right? And then, when you start reading the second part, you can just pop each corresponding letter one at a time, and the stack will just disappear down to nothing, which is exactly what you want. So the idea is, while reading the first half, you push exactly the letters that you see there. While reading the first half, push the letters. And then, while you're reading the second half, pop them, right? That's the idea. Yes?
So,
sorry.
Kind of like with the example we did yesterday, why don't you usually push like the letters onto the stack themselves and you use like placeholder type letters? Like how we're doing like A's and B's, we have like push S.
Yeah, last time we had something where A's, we were counting, for instance, like the number of A's matching the number of B's. This is actually the question that this insightful commenter asked me about. Yeah, and in those examples, I did something like, if I see A, I push X, and X is representative of a A, something like that. I would say you can do it either way. So rather than literally pushing A, B, A, you could push X's and Y's in that same order. I think, though, in this example, the letters are hardly, I would say those examples that we were doing before, the stack symbols were representatives of extra A's and B's, but here it's those exact letters in that exact order. So to me, it makes more sense to just push literally the A's and B's onto the stack, although you could do it with X's and Y's if you want to. I don't know if that's a good answer to your question. You can do it either way. In this case, I think is a little more natural to just push the letters exactly as they are. One thing you have to think about a little bit is just how do you sort of tell while the stack machine is going? You need to have some marker that designates the difference between these two behaviors, right? Like while you're reading the first half, you behave in a certain way, and then at some point you switch over to behaving in this other way, the second half. And you, for example, you don't want to go back to the first type of behavior while you're reading the second half of the string. So there has to be a specific marker, and there's sort of a trick. We're going to use the S, the starting stack symbol, to kind of mark the first half versus the second half. And in particular, we're going to, I'll say, during the first half, we're going to leave the S on the top of the stack. And you'll see how that can work. It's pretty easy to do. Let's just write the rules. So the rules, remember the way you write this out. Pop, push, read is first. All right. So if we are in the first, sort of the first stage of the analysis, we should see the S on top, because I said during the first half of the reading, you're going to leave the S on top. So it would look something like this. If I read the A and there's an S on top of the stack, that means I'm still reading the first half of the string. And what should I push on top of the stack is the A again. You're going to push those letters exactly. But remember, when I'm still reading the string, I also put the S on top at all times. So it looks like that. The S is there because I said I want to keep the S on top at all times during the first portion of the string. So when you read A, you can pop S and push SA. And same goes for B. Read B, pop S, push SB. All right, so these are the rules you use in the first half of the string when you are like loading up the stack, and you've got to keep the S on top. All right, at a certain point, you stop, you finish the first half, and then to signal that you're now reading the second half, you want to throw the S off of the top of the stack, and that is accomplished by an epsilon transition like this. Epsilon, S, epsilon. So at some point, you decide, I'm done with the first half. You throw the S away, and now we're going to do some rules which have, well, like I said before, the strategy is at this point, after you finish that stuff, the stack will now say AABA, and now it's just a matter of reading those same letters and popping them off the stack in exactly the same order. So I'm going to say read A, pop A, push epsilon. That is, if you see an A, you want to toss the A off the stack. And if you see a B, you want to toss the B off the stack. And if for some reason they don't line up in the proper order, the machine is going to get stuck. You won't be able to do one of those steps. And that's what you want, because if they don't line up in the right order, then it should get stuck, right? You don't actually want to accept the string in that case. So I think this is the whole deal. Let's just try one out. Let's try A, B, 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 A. All right? So I begin A, B, 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 A, and S on the stack. All right? Now, at any time, you can do that epsilon move. So it's kind of up to you to decide, when should I do that epsilon move? The answer is you should do it when you're done with the first half of the string, but before you start the second half of the string. So not yet, right? We should begin by reading the A. Do the rule number 1, right? You read A, pop S, push SA. Yeah.
The machine won't wait.
That's right. Yeah. How does the machine know when the middle comes? The answer is it doesn't. But to accept a string, remember, means that it is possible to get to the empty stack. There may be many alternative routes which lead to dead ends.
So the machine will do every steps.
I guess. I mean,
Every epsilon steps.
yeah. If you really wanted to make sure, yeah. I mean, the machine is just an abstraction anyway. But it's up to you when to use this step here. And just because I know how it's supposed to work, I'm going to use that step after I read the second B. It's kind of like an NFA in that case. In any given step, there are actually multiple choices that you could make, but only one of them is going to work out properly, and that's the one I'm going to choose. All right, next step would be to read a B, pop S, push SB. So this is now going to say B, 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 A, S, B, B. What's SBA? All right, and then I'm going to do one more of those, step number 2. Read the next B, so now it says BBA, and then it says SBBA. Now we have read the full beginning, and in order to sort of transition over to reading off the rest of it, I do the epsilon move in the middle. So epsilon S epsilon just doesn't change anything except throws away the S. And now it's BBA, BBA, and we're going to do the last 2 rules over and over again just to clear everything out. So I do the very last rule, makes a BA, BA, then the very last rule again makes it AA, and then the second to last rule makes it epsilon, epsilon, which is accepted. Yes?
Wouldn't this accept all the strings except like X of the comments or XR.
Yeah, it's a good idea. Like when you have these steps where there was a lot of choices that I made about which step to do, you should worry that maybe some other things will be accepted that are not what you want to be accepted. I don't think. What did you see? Do you have a specific example in mind that?
We can do like A, B, 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 A.
Okay, so A, B. How about that? Would that satisfy you? So if you tried A, B, A, A, then this would become B, A, A, S, A. Then I read the B, A, A, S, B, A. They won't match up. That's the issue. I throw away the S, I get A, B, A, and now this is stuck. Yeah, because you can only. It's these rules, like the fact that these are the same and these are the same. Yeah, great. Any other thoughts about that? How about slight variation? What about, that was X, XR. What about this? X equals X reversed. This is almost the same language. These are both certain types of palindrome strings. The only difference is this one additionally would allow one single letter in the middle, right? That's the only difference between this and the previous one. The previous one would be palindromes, which are even length. That's what this X followed by its reverse. But any old string which equals its own reverse, this is like above, but allows one extra letter in the middle. Anyone want to suggest a simple variation?
If there's one extra letter in the middle, wouldn't that make them not the same? Like, sort of?
Yeah, I mean, it could be something like A, B, A, B, A, B, A. So to break it down in this case, it breaks down like that, right? And then you have this extra thing in the middle. So to make a stack machine to accept this, it's going to be basically the same thing, only you need to give it maybe one extra bit of functionality to handle perhaps an extra letter in the middle. Any suggestion about how we could make it? I mean, and I would say exactly what the letter is in the middle doesn't even matter. It could be a B or a A. It makes no difference. You got an idea?
I was just going to say we would have two separate ones, one for A, one for B. So you read you pop a and then you push A.
Oops. I'm going to copy this because it's all the same. I'm just going to add to it. So you want to do pop. Did you have a specific suggestion? I would say I'm going to be thinking about this rule here. I don't want to get rid of that rule, but that's the rule that happens right in the middle. And it says you throw away the S without reading any letter. An idea?
You do read A, pop S, push epsilon.
Right.
And the same thing for B also.
Yep, that's it. So these two rules are similar to that one that I put the arrow next to. The one with the arrow says, don't read anything, just throw the S away. These two rules say, read a single A and then throw the S away. Read a single B and then throw the S away. You might be concerned that could you possibly do this rule many times to just throw away a bunch of extra letters? You can't though, because you're going to lose the S, and then you can only do that rule once. Yeah.
Couldn't you also just read nothing instead of A or B, or just that? Like, could you do epsilon instead of A or B?
Yeah, this is a good question, and this is something actually we're going to talk about in a moment. I never really told you precisely what are you allowed to put in this chart. Oh, this is not the question you're asking though. You are allowed to put an epsilon here. Is that what you meant?
Like, instead of doing, I don't know, I guess it would end up being.
It would say epsilon S epsilon, which is that one. Yeah. So this rule is necessary if there's no letter in the middle. This is what you use if there's an A in the middle. This is what you use if there's a B in the middle.
Okay.
Yeah.
Can you pop to letter?
Yeah, this is a question that I was sort of ready to address. Are you allowed to put epsilons here or more than one thing here? The answer is no. although I haven't ever told you precisely what are the rules about what you can do. Or are you allowed to read 2 letters at a time? The answer is also no. So this is what I want to talk about next, actually. Any more questions about this example? I'm done with this example. I would like to speak briefly, we're not going to make a big deal out of this, but just to address these questions, which I haven't actually totally answered yet. I want to talk about stack machines formally. Just like for DFAs and NFAs and grammars even, there is a formal description of a stack machine, which we almost never use, but is important just to keep straight exactly what is and what is not allowed in a stack machine. What counts as a stack machine? For example, are we allowed to pop the empty string? The answer is no. So I want to lay it out though for you. Basically what it is well, maybe I'll just go right into it. You have to think about what are the important ingredients in the stack machine. For a DFA, NFA, it consists of the alphabet, the starting state, the set of all the states, the transition function, and the set of all accepting states, right? What is important in a stack machine? A stack machine actually has 4 important ingredients. So this is the true definition of a stack machine, which we almost never use because usually it's easier to just write the chart of rules. But this is the true definition. A stack machine is a 4-tuple, and I'll use a M. M is for machine. What are the important ingredients? Well, there are 2 important alphabets, which we're going to write as gamma and sigma. That first thing there, that Waluigi thing, is a capital gamma. This is the Greek letter gamma. And then sigma, which is our usual letter for alphabets. And then S, which is the starting symbol. And then the delta, which is going to represent all those rules. But I'll say where gamma is, this is a finite set. And this is the stack alphabet. All right, usually for the stack alphabet, we use big letters, big S, big X, Y. Those the examples we did last time. In this example we just did, we also used the little a and the little b. But generally speaking, the stack alphabet will be different from the alphabet of the language, right? So this is the stack alphabet. Sigma is another finite set, which is the alphabet of strings that you use. This is called the input alphabet. S is the starting stack symbol, and that is just an element of gamma, right? S is one of the stack symbols. This is the starting symbol. And then the delta. The delta, just like for a DFA or NFA, we're going to represent the delta as a function. So delta is called the transition function, and I'll tell you what the domain and codomain is. Transition function. The idea is that delta is just going to represent, like, each value of delta represents one of these rows, and the way we translate, say, that row into delta would be something like delta of A, comma S equals the empty string, something like that. Although that's not, I'm going to sort of put this in quotes. That's not quite exactly how it would be represented, but the two columns there represent, we write them as a pair, A, comma, S. And then the answer is something. So the transition function, its domain is a set of pairs where the first thing is one of the input letters or possibly the empty string. This is confusing, but it's like that. This is the domain, oops, and then I'm going to put an arrow. So what this means is the domain is pairs. The first part of the pair is a letter from the input or epsilon. And the second part of the pair is a stack symbol from gamma. Sorry, I zoomed out. The first part is a letter or epsilon. Second part is a stack symbol. That's what all that fancy set theory means. This cross is what makes it into pairs, and then these two things are the sets where the two parts of the pair come from. And then, what does the answer look like? The answer, so this is basically the read column of the chart. This is the pop column, and then this is the push. The push can be any string of stack symbols, all right? And in fact, the push, we can have several rules. Now, I don't know if anybody noticed this. In this stack machine, that rule and that rule have the same read and pop, right? They both say read A, pop S. There's actually two different rules that tell you two different things. So the way that this delta works, and that's why this is not quite accurate. Should I big underline the inaccurate thing? Not really. That's not quite accurate because you can have possibly more than one answer to this delta, right? What is delta of A comma S? Well, in this example, it could be SA, but it also could be epsilon. So really the correct way to write this is, it is the set SA comma epsilon. You can get possibly two answers from this particular stack machine. So the answer is always a set of strings from gamma. So I see the question, I'm just gonna write that first. A set of strings of gamma. What that looks like is, gamma by itself is just individual letters from gamma. Strings of gamma would be gamma star, right? That means strings which are made up from gamma. And a set of strings of gamma would be this, power set of gamma star. How you like that? This means the answer is a set of stack strings. This is very complicated when you write it out, but it's not so hard to actually write down what the delta is for a given example. Do you have a question about something?
Yeah, so it's basically like NFA, so you can have multiple outcomes.
Yeah, that's right. Yeah, the same input can possibly give you multiple outcomes, even if the stack symbol is the same. Yeah. All right, so let's see if we can just, the usual thing is, like, if I show you a stack machine, can you translate it into this formalized description? It's always easy to do. I thought we should just do an example, though. How about, let's try, here is a stack machine, which I'll write in the ordinary way with the read, pop, push. Let's say read A, pop S, push S1. I'm using a 1 on the stack here. Read B, pop 1, push epsilon. Read epsilon, pop S, push epsilon, and read epsilon, pop S, push 1, 1. All right. This is a stack machine. Can we write the formal description of this stack machine? Write it formally. There's not much to it, you just got to do it. I didn't mean for that to sound cute. Remember, it has 4 parts, right? The M is going to be a tuple of 4 parts. The first thing is gamma, which is the set of stack alphabet symbols. So what can I see possibly on the stack? And you can tell from the chart here. S could be on the stack, and what else? 1, yeah. Anything else?
Epsilon.
You may wonder, should I include epsilon as part of this? The answer is no. Thank you for saying that, even though you said no. Yeah, epsilon, remember, is not actually a letter. It is representative of the empty string. It represents no letter at all. So epsilon itself does not count as a letter. All right, this is the stack alphabet. Yeah? Epsilon is part of gamma star, but it's not part of gamma.
Why is we have to signal the union with epsilon with delta?
Yes, that's right.
Why?
Because So right here, sigma union epsilon, this is because the read is allowed to be epsilon. So if you put only sigma here, then the first part, the read part, could only be A or B, but not epsilon. The first part of the pair is what you see in the read column, and the read is allowed to be epsilon.
Because I thought epsilon is also part of sigma.
No, epsilon is not a letter. It represents the empty string. So this sigma in our, well, we're about to say, what is sigma in this example? What is it? A and B, yeah. Also does not include epsilon. Epsilon is not a letter. It's the empty string. All right. And what's next? The stack, the starting stack symbol, which you should always just assume is S, unless I say any differently. We assume that the starting stack symbol is always S. And then the delta is a function. So just like for NFAs and DFAs, I'm just going to write delta there, and then underneath I will say where. And now I just have to describe every value of delta. So delta, and you basically translate each line of the stack machine into a different value of delta. Anyone want to say what's the first line translate as? Yeah.
Delta A comma S equals, and then the other thing in there is S1.
Yes, the set of S1. Great. That's the first line. Delta of AS is the set of S1. The second line, similar. Delta of B1 equals the set of empty string. Oops. That means when you read B, you can pop 1 and push the empty string. All right? Yeah?
Can you just say empty string, or do you still need to include it in the set?
It needs to be in a set, because everything that I write as on the right side of these equal signs must be a set. The empty string by itself is not a set. This is different from the empty set. The empty set would be nothing at all, which is different from the set containing the empty string. Yeah. Let's continue. What else? The other two lines are epsilon and S. So I got to say delta of epsilon S equals. And here you have more than one thing in the set. From the third rule, you could get epsilon. From the last one, you could get 1, 1. So this is the set epsilon 1, 1, like that. All right. This is almost it, but not quite. Why is this not quite everything? It's because I have to tell you what all possible values of delta are. All right? Delta is a function with domain, like we said before, and a codomain. I've only actually told you what a few of the different values are. I didn't tell you, for example, what is delta of B comma S? It is the empty set, right? So the question is, what can you do if you read B and pop S? The answer is you can't do that, and so there is no answer for delta of B comma S. But because delta is a function, you need to say what its value is on all of the possible pairs in the domain. So I'm going to write a whole bunch of extra stuff having empty set as the answer. It could also be delta of let me just finish writing pairs which have S as the second part. It could be delta of epsilon S. That is also, that's not empty. I actually already wrote that. Okay, so let's do everything comma 1. It could be delta of A comma 1 is empty. Delta of B comma 1 is empty. And delta of epsilon comma 1. Sorry, B1 is not empty. It is the set containing the empty string, which is not the same as the empty set. Your discrete math teachers always told you this day would come when there was an important distinction between the empty set and like the set containing the empty set. They are different. Usually it's just silly talk, but it is important in this example. Have I written down all possible pairs? I think I have. Yeah, I think so. All right. You could say, writing somewhat informally, you could, I suppose, write it this way and then say delta of x comma y is empty set for all other pairs x comma y. If you want, you could say that, I suppose. I don't know if you like that any better.
So
Yes?
you just go through all the pairs and like, even if it's not there, that's just when you did the empty.
Yeah, you go through all the pairs. If you see them in the list, you give a real answer. If you don't see them in the chart, it's the empty set is the answer. All right. Great. I think actually it's about time to go. Next, what I want to do next is a formal definition of that. What exactly does that symbol mean when you write it in a stack derivation? But we'll do that next time.